8.1. In this lecture video, we're going to talk about the real number lines and absolute value. This particular video, I'm going to mentioning something called classifying our different types of numbers. All right. So let's think back. At the very beginning, back in Module 1, I mentioned the wording real numbers. Real numbers are numbers that are on the number line, such as fractions, decimals, and whole numbers. So all the numbers on the number line are considered as a real number. All right. So under the real number, because there's actually something called non-real number as well, but here we're just going to talk about classifying real numbers. So under the real number, there is something called the rational numbers, which is just another word for fraction, and there is irrational numbers. So in a minute, when we do this example, the first thing we want to do is talk about the first thing we're going to be able to identify is rational versus irrational numbers. So rational numbers is a number that can be written in the form of a over b, which is fraction, where a and b are integers, where denominator can never be zero. So rational number is just another word for fraction. So here I have another definition for rational number, which is a number that can be written in decimal form as terminating decimal or as an infinite repeating decimals. So what that means is any decimal numbers, if the decimal places is terminating, for example, like 2.45, okay, if my decimal places is terminated at the 100th place, okay, then this decimal number can be converted back into a fraction. All right. If I have some sort of repeating pattern on the decimal places, then such decimal number can also convert back into a fraction. So the word rational means fraction. All right. And we know fraction can be divided where we have decimal places. If I have terminating decimals, then such decimal number can convert back to a fraction. Or if my decimal places does not terminate, but it shows some sort of repeating pattern, then those can convert back into a fraction. All right. So what is an irrational number? Irrational number simply means decimal places does not end, and the decimal places shows no repeating pattern whatsoever. The perfect example is a pi. A pi is not just 3.14, but it's actually 3.1415926 ... Okay? The ... means the decimal places never ends, never terminates, and the decimal places also shows no repeating pattern. So those kind of decimal numbers is considered as an irrational. All right? Natural number or counting numbers, okay? Our notation is this symbol, look like an N. All right, so what's considered as a natural number is begin with 1, okay? Or we can call them counting number. It's go from 1, 2, 3, 4, 5, so on and so forth. The difference between a natural number versus a whole number is whole number actually contains 0. Natural number does not. All right, so whole number is from 0, 1, 2, 3, and keep on going. All right, integers. Integer is the set of number consisting of whole numbers and their opposite. Opposite in algebra means opposite sign. So normally we just say integers are positive and negative whole numbers. Now notice that 0 is actually considered as an integer as well. All right. So every time I use the word integer, it's referring to positive and negative whole numbers. So let's try some example real quick. The number 11. All right. First thing we're going to compare is rational versus irrational. 11 is considered as a rational number because 11 can be written as 11 over 1, which is a fraction. Every time I have a fraction, it's a rational number. 11 is also an integer. Integers are positive and negative whole numbers. So 11 is a whole number. 11 is also a natural number because natural number is from 1 keep on going to the right on the number line. Whole number just have a actually start out with 0, 1, 2 and keep on going to the right on the number line. So 11 is all four of these. All right, negative 13. Well, I can write negative 13 as negative 13 over 1, so that's a rational number. All right, it's an integer. Integers are positive, negative whole number. But it's not a whole number this time because whole number and natural numbers is actually counting starting from 1 go to the right on the number line or from 0 to the right. So it does not, so whole number, natural number does not contain negative. So it's just these two. Negative 2.09, okay? Then, so this is a decimal number and my decimal place ends at 9. So if it's terminating, it's a rational number. It's not an integer because integers are positive and negative whole numbers, okay? But so this is not a whole number, this is a decimal number. So it's not an integer, it cannot be a whole number, and it's not a natural number or a counting number. So if I have a positive 2.09, that will again just be a rational number because this is a decimal number, so it cannot be integer, whole, or natural. All right, this decimal number, 2.77 ... So this is actually 2.7 repeating. So decimal places never ends, but it shows a repeating pattern. So this decimal number can actually be converted back into a fraction. So it's a rational number. All right, since 2.7 repeating is a decimal number, it cannot be integers, whole number, or natural numbers. All right, this is an interesting one. This decimal number appears to be a repeating pattern. Negative 5.151151115. See, that's not actually a repeating pattern. What we're looking for is repeating digits that repeats. So if this decimal number is like a negative 5.15151515, then that's a repeating pattern. This is actually not a repeating pattern here. All right. So no repeating pattern, decimal never ends, is considered as an irrational number. Okay. So if it's an irrational number, that means it consists of decimal places and is non-terminating. So decimals are not integer, whole number, or natural number. Now 0 is the toughest one. 0 is actually a rational number. 0 is tricky. 0 is a rational number because I can write them as 0 over 1, which is a fraction. 0 is an integer. Integer actually includes 0 actually includes inside the integer. 0 also includes on the whole number. However, 0 is actually not a natural number or counting number because natural numbers or counting numbers start out with 1, okay, not with 0. All right. So in this video, we just quickly talk about the different classification of real numbers. Okay, we have rational numbers, which is fractions, or decimal places ends, or decimal places show repeating pattern. And we also have natural numbers, integers, and whole numbers. All right, that will conclude this lecture video. Thank you for watching.